So uh, what I was telling was that scalars are quantities which need only magnitude to be described fully. So if I tell you like some examples of scalar quantities are mass, length, time. So if I tell you that something is 10 kilograms or something is 1,000 milligrams, so you can just tell the mass. So that 10 kilograms and 1,000 milligrams is completely describing the quantity, that is the mass. Similarly, the time, some examples of time are 5 seconds and 10 minutes and 2 hours. So the specific definition, the specific magnitude of 5 seconds is itself describing the quantity fully. We write it describing it fully. So this is what the scalar quantities are. Now, you might be wondering, why am I emphasizing on describing something fully? So the next type of quantities that we're going to talk about are vectors. So vectors are something which requires magnitude and direction as well. Okay.
Yeah.
So let's say uh, let's say I'm pushing this block. Okay, I'm pushing this block and I'm applying a force of say 15 newtons at some angle, okay, theta. And now I tell you that I have stopped this force, stopped the movement by 10 newtons. Then what will you say? What will you think? You don't know 10 Newton, uh, did I apply 10 Newton on this? Was I applying it in this angle or this angle or this angle, or was I horizontal, or what was the case? So I basically don't know you. There is no way for you to know that how did I apply this 10 Newton when I'm only giving you that information that I apply 10 Newton force to stop this block, stop the movement. Do you get it?
Yeah.
So I'm just gonna repeat it. So let's say that someone was applying 15 newtons to it, and obviously if I apply force to an object and according to the Newton's laws, this object moves. Is that correct?
Yeah. Yeah.
So to stop the movement, I need to apply some force from the right side to actually stop the movement. Is that right?
Yeah.
But when you ask me, but I just tell you that I applied 10 newtons of force to stop this block.
Mm-hmm.
Now you don't know what 10 newtons, how much, at what direction, in what direction I actually applied these 10 newtons. Was I actually horizontal? Was I on an angle? And how much was the angle? You have no idea. Okay.
Yeah.
So that's pretty much it. To describe this force fully, this quantity fully, the force, I need to specify the direction as well. I'm just going to write direction needed. Okay.
Yeah.
So vectors are basically quantities which need magnitude as well as direction as well to be described fully. So some examples of vectors are forces. So force is a quantity. Then there is velocity. There is acceleration. There is displacement. Okay. So these are some examples of vectors. Now that we have some basic idea of vectors, we can move on to their representation. Is that clear? Is the everything
Okay.
that we've, yes?
Yeah.
Is everything that I've taught so far, is everything clear?
Yeah.
Okay. All right. So let's discuss a vector. So first of all, vectors are, sorry, just 1 second. Yeah. So first of all, the vectors need to be represented using a line segment, which means that it has a starting point and it has an ending point, all specified. So it cannot be a line where I don't know where it is ending. I need to know, to represent a vector, I need to show the starting point and the finishing point. So this is like something like this, where I'm telling that, okay, this is the starting point and this is the ending point. Clear? Okay.
Yeah.
Okay. Now, what happens when I draw a vector in a Cartesian plane? Now, do you know what a Cartesian plane is?
No.
Okay. So Cartesian plane is basically this graph.
Okay.
So this block of squares is basically what uh, Cartesian plane is.
Okay.
Wait, just give me a second. I'm getting a call.
Okay. Yeah.
Okay. So if I have to describe a vector here on the Cartesian plane, what I would do is I will make a starting point and I will make an ending point. Okay. So
Mm-hmm.
this was the starting point and this was the ending point. And this is the direction of the vector. Okay.
Yeah.
So now now I can represent this line on a column matrix as well. I can make this line on a column vector as well. Do you know what a column vector is? Column
Um. mm,
a column vector is basically a matrix which has only one column. So it doesn't have it has only like one column with information like written like this, C, D, E, and so on. Okay.
Okay.
So it's like a one column matrix. Okay.
Mm-hmm.
So we describe this line of a vector using a 2 by 1 column matrix. So to describe this line, let's call this A. We need to have this is a 2 by 1 column matrix. So there is one entry here and second entry here. So we need to have two values that need to describe this line fully. So how will I do it? So on the first entry, we always write the x value, and on the second entry, we always write the y value. So this is like the this is how it is. This is the correct notation or whatever you want to call it. This is the correct way to write the column vector. So in the first entry, you write the x value, and then the second entry, you write the y value. So we also call them components of the vector. We write them as x component, and we call them this one the y component. Okay.
Yeah.
So okay. So now what we're left with is that what these x values and y values are. There has to be a value. Okay. Now the x value. Now what we do is we make a right angle triangle like this from the starting point and the end point. And then we simply count the number of units on the horizontal and the number of units on the vertical. So here the horizontal units are 2, and so because it starts at 2 and it ends at 4,
Mhm.
so it's 2. And similarly in the vertical, in the y component as well, so it starts at 2 and it ends at 4, so this is 2. So vector A can be x is equals to 2 and y is equals to 2. So A is actually equals to 2, comma 2 or 2, 2. So this is one way to write a vector.
Okay. Yeah.
Okay. So now let's do another example. Let's look at the exercise. So do some examples so that you know about. So you see on the horizontal plane, it's always the x component, and in the vertical plane, it's always the y component. So this is the x component, and this is the y component. So if I want to write PQ, I will write it as 4, which is the x component, and 3, which is the y component. You get it?
Mhm.
Yes?
Yeah.
Okay.
Yeah.
That's great. That's great. So, okay. So try to get this diagram now. We have for this vector,
Mhm.
we have 2 in the positive direction and -3 in the negative direction. So because it's down, down is always negative. Okay.
Yeah.
So if this was vector A, A would be represented as 2 minus 3. Do you get this?
Yeah, but is right always positive direction or
Yeah, the the right direction is right is positive x and
Mhm.
up is positive y. It's always the case, and down is negative y. Similarly, left is negative x. So,
Okay.
and this in this thing, so this was the starting point, and this is the ending point. So the if we make a triangle like this from starting point to the ending point, you would see that we have to go left 4 units and we have to go up 5 units. So left 4 units and up 5 units. So left 4 units means -4 in x, and up 5 units means +5 in y. So we will represent, if this is vector b, we will represent b as -4 +5. Do you get this? Is it clear?
Yeah. Yeah.
All right, that is great. So to do some questions. So let's now write some column vector. Let's practice this. Okay. Let's
Yeah.
write the column vector of AB. Okay. So A
Mhm.
is the starting point and B is the ending point because that's where the arrowhead is. So we're gonna make a triangle like this. So for AB, we need to go left 4 units
Mhm.
and up five up. When we go up 3 units. So left 4 units means -4 in x,
Mhm.
and up 3 units means +3 in y. So AB, the column vector for AB would actually be -4, 3. Do you get this?
Yeah.
Okay. Now let's do this RS vector. So
Mhm.
RS vector is basically a horizontal vector, or it's something where we don't have to move in the y direction at all. Is it true? Like, is it true for me? Is it correct of
Yeah.
me to assume that from to go from R to S, I don't have to move in y direction at all?
Yeah, it's true.
That's true.
Mhm.
So, if I don't have to move in the y direction at all, that means that the y component is actually 0 for RS. Okay.
Yeah. Yeah.
And what's the x component? X component is
-2.
-2. That's correct. Why? Because 2 in left.
Mhm.
So RS vector will be represented as -2, 0. Okay.
Yeah.
Can you tell me what is the column vector of TU?
Tu is just 40.
40,
I mean 04.
04. Are you sure?
Oh wait, no, it is 40.
40. It's actually 04. Why?
Oh.
Because that's why I asked if you're sure or not. Because there is no movement in the x direction. So
Mm-hmm.
no movement in x implies that x component is equals to 0.
Mm-hmm.
Okay.
Yeah.
So TU is 0, 4. Okay. Tell me the remaining ones. Tell me the column vectors of CD and P and Q.
Uh, CD is -1, -1, +1. No, I
Please.
mean 2. -1, 2.
So CD, we're going from C to D.
Mm-hmm.
So -1 means you're going one in the left direction, which is here.
Uh, um, +1 -2.
Yes. +1 minus 2. Why? Because
Because it, yep.
you go one in the on the right and 2 down. So
Mm-hmm.
one right and 2 down. So it's 1 minus 2. What about P
Yeah.
and Q?
P is +3, 3.
Okay, so what's P? P is
3, 3.
3, 3. That's correct. Shabash. And what's Q?
Q is -2 and -1.
-2 and -1 is correct. Yes.
Mhm.
Okay. So now, just one thing, like remember this formula for a column vector xy, the magnitude is given by under root x square plus y square. Okay.
Yeah.
So what's the magnitude of CD here? CD is actually under root 1 square plus -2 square. 1 plus 4, which is under root 5. So this is the magnitude. If we talk about the magnitude of P, magnitude of P is 3 squared plus 3 squared, which is under root 9 plus 9, which is equals to under root 18. Do you get this?
Yeah.
Okay, what's the magnitude of 2?
Of 2. Well, Wait, what do you mean the magnitude of 2?
Magnitude of Q.
Oh, Q. Minus 2 squared plus minus 1 squared all square rooted.
That's correct. So this answer is under root 5.
Mhm.
And what's our S? Our S is minus 2 squared plus 0 squared. So the answer is plus 2. Okay.
Yeah.
All right. Okay. Can you do question number 8? This question.
Mm.
Just do question number 8 and send me the solution. Okay.
Okay. I don't really get it.
Yeah. So this means the magnitude. So the lines around AB means
Mhm.
AB actually means that magnitude of vector AB.
Okay. I got AB equals √7 and CD equals 5. No.
Did you not square them? It's actually
Yeah, I did.
so the magnitude of AB is equals to root minus 3 squared plus 4 squared, which is equals to 9 plus 16, which is equals to under root 25, which is 5. And CD is equals to 0 square plus 5 square, which is equals to 0 plus 25, which is equals to under root 25, equals to 5. So magnitude of AB is equals to the magnitude of CD. Do you get this?
Yeah, yeah.
So that's pretty much the way. Now they're asking in the part 2, explain why the vector AB is not equals to CD even though their magnitudes are equal. Okay. Now
Mhm.
let's head back to our Cartesian plane. Where is it? Where is it? Okay, here it is. So a B, sorry, AB was actually -3 4, and CD was 5 0. Okay,
Mhm.
so to draw AB, I'll just write the -3 to the left, -3 to the left, and 4 up. So and this is this is point A and this is point B. Understood?
Okay, yeah.
And about the CD, CD is just C. This is C, and this is the point D. So
Mhm.
these two vectors are no way equal. So for two vectors to be equal, they don't have to be equal in magnitude. They have to be equal in component as well.
Mhm.
Is that clear?
Yeah.
Okay. So now let's do some advanced concepts. Let's say you have a force which is applied. This force is of 5 newtons, and it makes an angle of makes an angle 35 degrees with vertical. So this angle is 35. How will you represent this vector in a column matrix, in a column vector? So
Um, yeah.
what you're gonna do is you're gonna stick to the same thing and make a triangle that we make obviously. So this is the vertical component and this is the horizontal component, and this is a right angle. So this angle is 35, which means that this side is 5 sine theta, 5 sine 35, and this is 5 cos 35. Okay.
Yeah, yeah.
So if this is force F1, then F1 in a column matrix is actually written as -5 sine 35 and -5 cos 35. Is it clear?
Yeah.
So, and let's say there is another force F2 with magnitude 6 newtons, and it makes an angle of 40 degrees with horizontal. So this is the horizontal. This is the horizontal, and it makes
Mhm.
an angle of 40 degrees. Okay.
Yeah.
Now, how will you divide this 6 newtons into? How will you divide this 6 newton into a represent this into a column matrix in a column vector? Again,
Um,
yeah,
yeah.
yeah. You go ahead.
It would be uh cos I mean 6 cos wait 6 6 cos 40
Why is it 6
over
cos 40?
no 6 cos 40 is it
Because this is a right angle, and the right angle triangle
mhm,
that we made is just shows that this angle is 40 and the hypotenuse is 6. So this is going to be 6 cos 40.
mhm,
Okay. Subsequently, what will be this side, the vertical thing?
6 sine 40 oh no a tan
Yeah.
no yeah 6 sine 40 no.
Are you sure? Are you sure this is the right answer?
um um
Mm,
for vertical yeah
yes.
mhm.
Is the is it the right answer? Just like I want you to be confident on the answer.
I think so.
Just just try, kind of recall the concepts that we've learned today when representing a line by a column vector. What we are
Mhm.
doing here is that in the x component, we're basically writing the distance that is required from starting point to end point horizontally. So in the x component, we have to write, if this is the starting point and this is the ending point, we need to find this distance. Okay.
Yeah.
And similarly, in the y component, we need to find the vertical distance.
Mhm.
And if we know we know that this line, the length of this line is 6 newtons. The magnitude of this vector is 6 Newton, and the angle that it makes with the horizontal is 40 degrees. It is all that is given to us. We can calculate using trigonometric ratios. We can just say that this horizontal distance is 6 cos 40 and the vertical distance is 6 sine 40. So in the horizontal distance, that is 6 cos 40, it's actually towards the right. So we'll just write positive 6 cos 40. And the vertical distance, it was upwards 6 sine 40. That's why it is plus 6 sine 40. So actually this answer is correct.
Mhm.
Okay.
Yeah.
Okay. So now, why are we doing this? Why are we writing these vectors f1 and f2 in column matrix? Because this helps us to do find the resultant force. Now I'll just show you how easy it is for us now to just calculate the resultant force. So the resultant force is F1 plus F2, which is basically minus 5 sine 35 and minus 5 cos 35 plus 6 cos 40 and 6 sine 40. Okay.
Okay.
So you just add the x components and you just add the y components, and you will have a new vector. You will see that you have a new vector and column vector for this thing. So if I can calculate this, 6 cos 40 minus 5 sin 35. So 1 point, this is 1.72, and this is minus 0.24. So this is the actually the resultant force. Okay.
Yeah.
Now we can also actually calculate the magnitude. I mean the size of the of this of this resultant force. It will be just equals to under root of 1.72 whole squared plus minus 0.24 whole square. So by doing this, we are actually calculating the the size of the resultant force. So this is actually equals to 1.73 newtons. Okay.
Mm-hmm.
So it's actually making things easier for us. Okay.
Yeah.
Is everything clear with this?
Yeah. Yeah.
Do you have any questions?
No.
No? Are you sure?
Yeah.
Do you want me to repeat anything or something?
No, it's okay.
Okay, so now let's attempt this question that you sent me so that it's easier for us.
Mm-hmm.
Why am I doing this? This question is actually asking you to calculate the resultant force of A and B. Resultant force of A and B. Okay.
Yeah.
Now, what's the column vector of A?
Um, two. What is it? Two.
Hmm?
Yeah. 2, 3.
2, 3. That's correct. What's the column vector of B?
6, 2.
6, 2. Very good. Shabash. Now, what's the resultant force? The resultant force is A plus B, which is 2, 3 plus 6, 2.
8.
Yeah, 8 and
Yeah. 5.
8 and 5. Okay.
Mm-hmm.
So it's now easy. So this is 8 and this is 5. So we can
Mm-hmm.
say that this is the magnitude of the resultant force A plus B. Sorry, this is the vector, the resultant vector A plus B. If we want to find the if you want to find the magnitude of the resultant force, we can just calculate the magnitude of this column vector. Is that correct?
Okay. Yeah.
So this is 8 squared plus 5 squared, which is equals to 64 plus 25. which is equals to root of 89. Okay.
Yeah.
So this, see, now that we have basic concepts of vectors, we are actually able to solve these questions easily.
Yeah.
Okay.
Yeah.
All right. So I think we've done most of it that's required, and what I would like you to do is actually, revise this concept. I will email you this whiteboard,
Mhm.
and we'll make sure that you keep practicing. Just make sure that you sort of, whenever you're like practicing, and if you get stuck, you can like email me the question or send me a question on WhatsApp. I'll just help you there as well. But the goal is to, keep working and keep working on these basic concepts. So this is like a very basic, but it's a very important concept that's taught to the A-level students. But I'm glad that we did this today. Okay.
Mhm.
Chale. Do you have any questions from the class?
No.
Hello, are you sending me a question, or
Oh, no, I said I had no questions. No.
you don't have any questions?
No.
Okay. So he, all right, let's end this today's class, and I'm gonna meet you next week, inshallah. Probably
Mhm.
on Wednesday or Thursday, whatever you like. Just drop me a message. Other than that, are you just for my feedback? Are you like okay with the pace that I'm going at? Like some students find the teacher's pace too fast, some find it too slow. So is the pace that
No.
I'm going at right now, is that okay with you?
Yeah, that's fine.
All right, Sarah. Chale, it was nice talking to you today. Inshallah, I'll see you next week.
Mhm.
Allah Hafiz.
Bye.